40 minutes and have a very low yield. But because we're going to use this gravity pressure vessel as our continuous pressure cooker, we can actually achieve incredibly small, short duration cooking at a high temperature, then recover the heat that is in the water and achieve yields of 70 to 80%, as opposed to the 10 to 20% that has been achieved in the past. And again, this is the device that's actually doing it. We have an animation here to show you this in greater detail. But it's pressurization, cooking under pressure at high temperature with no moving parts at all. We don't have to pump up the pressure. The pressure exists at the bottom of this vessel. This is about 2,000 feet into the ground. But that gives us adequate pressure so that we can do this pressure cooking in short order. See if we can get this to play for you here. Oops, no. Back. Try this. Now we're not getting enough sound here. Technical difficulty. How did we muster the sound level on that before?
The gravity pressure vessel is a kind of pump that can process hundreds or even thousands of gallons per minute with no moving parts. Water carrying tons of solids per day is drawn down into the closed system, gaining pressure as the mash descends. It is heated by the fluids coming up from the bottom of the vessel. When the mash reaches the three-stage reaction chamber, it is under full pressure and has been preheated. In the first reaction chamber step, oxygen purges the mash and provides heat. Next comes carbon dioxide, which provides a weak acid that breaks down the fibers into sugar. Next, the acid is stopped using quicklime, which fixes the sugar. The sugar in the water rises in the gravity pressure vessel and is cooled by the descending mash. Most of the heat remains in the vessel. The outlet chamber separates the lime and metal oxides from leftover gases from the water and sugar solution.
The importance of public acceptance really cannot be understated. In a deliberate effort, when we go into a community, we sit down with the people who are responsible for the guarding of the environment and so forth, and carefully explain to them what we're doing, how we're doing it, how we're going about it, why our process is different than other processes. And quite frankly, we have consistently been able to enjoy their endorsement when we respect them, when we go to them, when we talk to them about it, we answer their questions, we go to their public meetings, we go to their public hearings, make our presentation, and it makes a big difference. And that way they become a partner to it. But we really need to stress the importance of having the community behind what we're doing. If the community doesn't want us there, we really can't go. The other thing is that we want to take maximum advantage of the available local working staff, working capability. We normally typically do that in conjunction with a technical college or a local university that helps train our people right from the local population. This is a little closer view of the actual, no? Back again. Yeah. Maybe you didn't try this.
The plant to convert a city's wastes into ethanol would fit in an industrial park in the host community. This plant has no smokestacks, chimneys, or flares. Everything is enclosed. The same trucks that collect the wastes from the community enter the separation building and drop the wastes into a shallow basin. The wastes are then lifted into a heavy-duty industrial washing machine. After washing, plastics and bottles float are separated and then recycled. Metal items, sand, grit, and glass sink are separated and then recycled. Roughly chopped paper scraps, food scraps, yard wastes, wood scraps, farm wastes, and all their fibers remain in the water. These fibers are chopped and processed a second time. These fiber materials are then thickened and blended with organic sludges, septic and pulp wastes, and cooked down in a gravity pressure vessel to make sterile sugars and nutrients. After cooking in the gravity pressure vessel, these sugars are cleaned, filtered, and then thickened in preparation for fermentation. The two-stage fermentation produces ethanol or butanol. The leftovers are converted to methane. The biofuels are then cleaned, polished, and sold. Yeast from fermentation is made into a high-protein feed supplement and sold. The wastes of the city do not have to leave the city. The finished biofuels are marketed in that same city. After internal recycling, the plant produces an excess of clean water. This plant is a major step to a zero-waste community.
This little quick slide here, what happens if there's a failure of employee training? This happened right by our home. It's a nightmare for electrical distribution, but sometimes you can't push a system beyond what it can actually carry. And somebody said pull the plug, somebody said no, it can take a little more extra. The result was a pretty serious blackout. We also take extra care in making sure that we have adapted the process to every local stream. Even though there are a dozen plants around the world, no two are the same. And each one has to have its own analysis of what the materials will yield and how to go about the engineering design. No two plants have the same engineers, no two plants have the same funding or insurance carrier. We break down over 99.9% of all the suspended solids are converted to dissolved organic material, primarily materials that are amenable